Dear viewers, my partner Frank Cevallos and me, Julissa y Aucancela, we have the honor of presenting the design of a machine for drying polypropylene powder produced in a mechanical recycling plant. But first, we must understand the context of the components. A company of a mechanical recycle have the function of recycled polymer to produce pellets. This company is ubicated in Guayaquil and have an important problem relations with its activities. First, recycle plastic to introduce the process of trituration and wash it. After, the plastics are drying, but in this point exists a loss of powder polypropylene. This rejection is harvested to apply the natural dye, but this form of dye not satisfy the demand. In June, we take a sample of 32 tons of raw material, but after to these processes, we receive 29.7 tons. It's evident the difference between the masses because in this difference exists 5% of impurities and 2.5% of polypropylene. The principal objective is to design a plastic dust dyer generated in a mechanical recycling plant to reduce the material losses from the current process. But, firstly, investigate the types of dryers in the market to select the most efficient machine. We determine the parameters necessary for the drying the plastic. Finally, we will do an economic index for the project throughout the quotation of materials. To understand the project, we must know that the polypropylene is now a hygroscopic and semi-crystalline material. The done is 46% to the in the machine. The company used the dry extraction and the filtration and sedimentations are an important parameters to analyze the system. Finally, as an extra model, we will put a storage silo.
Before choosing a solution, we have three alternatives. Centrifuge machine that consists of separating water from solid by the action of a centrifugal force. It doesn't need to control the temperature and its capacity is around 500 to 800 pounds-hours. Fluid bed dryer that consists of supplying an airflow. This flow should have a speed capable of withstanding the weight of the material. This material will behave like a fluid, increasing the heat transfer. Its capacity is around 15 to 5,000 pounds-hours. Hot air dryer that consists of supplying a hot air flow, and with the help of the heat transfer, it can remove the damp. Its capacity is 50 pounds-hours. To choose a solution, we make a matrix decision. The characteristics more important are inversion cost, operational risks, and performance. Analyzing the matrix decision, we have like the best solution, the centrifuge machine. The company has another centrifugal machine of a smaller size, which will serve as a reference to redesign and reduce the humidity.
Now, we will expose the data analysis. We're using the equations for the centrifuge force and the ampersand. We obtain the radius of Medius filter and the necessary force to separate the polypropylene to the damp mass.
The function of the keep is to separate the liquid from the water. This is caused by the sedimentation. In the slides, we can see the equations to calculate the sedimentation speed, the sedimentation time, and the sedimentation capacity of the machine. After sedimentation, the keep should filter the water, but not all the water can be filtered in the same time. This phenomenon is caused by the resistance of the material and the filter media. So to calculate the flow that is filtered, we have to use these equations.
According to the analysis career, the results are shown in three forms. The company must apply a cleaning procedure over to the medium filter based in the ISO or 565 of 1990 norm. In the better case, it's recommendable change the filter, where the porosity diameter is 0.85 millimeters.
Now we can see that the angular velocity is inversely proportional to the humidity. Now we can see the results of the sedimentation parameters. We can see the dimensions and velocities of the pulleys and belts. The keep with a saturation of 90% the humidity of the material will be 8%, so it's impossible to reduce the humidity in a 0%.
As an implementation for the project, we did a storage silo and based it in the UNE-EN 1991 to calculate the dimensions. Furthermore, due to the type pulverulent of material, we used EN 14,491 to 2006 European norm. To do the dog material guide, we calculate the pressures due to the air and the plastics to finally find the head the system.
Now we analyze the project economic index. The project cost is 8,251 and the investment will recover in 3 years.
In conclusion, the centrifugal machine of the company could work in the perfect condition if maintenance were performed according to the norm, and in addition, the mass change is given by the same standard.